Hello and welcome to this video on finding the nth term of a linear sequence. So hopefully you've seen the previous video, which was when we were generating a sequence, so subbing in our term values. So first term we sub in 1, second term we sub in 2, third term we sub in 3, so on and so forth. But now what we're looking at is we're looking at working the other way. So we've got our sequence and we want to find out what the nth term is in case we want to generate one of our other terms. It could be like the 50th term, the 60th term, whatever it is. So let's have a look at this one. Do make sure you get it in your notes. Remember, the only way to learn maths is to do it. So this is our first example, and it says find the nth term for the formula. Find the nth term formula for the sequence 1, 3, 5, 7, 9. Okay, so let's get this one down. So this one here is example 1. Super. So with example 1, let's write it down first. So 1, 3, 5, 7, 9. Now, there's lots of different ways that you can do this. I don't tend to like kind of tricks with maths. I want you to usually understand it. But I do actually think that with this one here, that the phrase Dino does help us. Now, Dino, it's probably worth getting this in your notes. So, Dino, like this. This stands for, the di stands for the common difference, and this 0 stands for the 0th term, and the n is for the nth term. So you'll see how this works in a second. So if I, first of all, with this one here, there's two things I need to work out, and that's the common difference, so what it's going up by, and then the 0th term. So for this one here, I'm going up by, well, what am I going up by here? I'm going up by plus 2, plus 2, plus 2, plus 2, which means that this here, this difference is 2, okay? So it's going to be 2, and then the n, which is there. Now, the other thing that we're missing is this 0, so the 0th term. Well, we know that this is our first term, second term, third term, fourth term, fifth term. So to find our 0th term, we go backwards. Let me do this in a different colour. So instead of adding 2, I subtract 2 there. So 1 minus 2 is equal to minus 1, and this is our 0th term. Okay, so it's going to be 2n minus 1. And there we have our linear nth term. So if you were to sub into this, let's try subbing in 1. So 2 times 1 minus 1. Well, 2 times 1 is 2, minus 1 is 1. 2 times 2 is 4, take away 1 is 3. So the second term is 3. 2 times 3 is 6, take away 1 is 5. So this is the linear nth term for this sequence. Super. What I'd suggest, have a little go at that one on the right hand side. I think if you still not too sure, then maybe wait, but pause now and have a little go at that one on the right. Okay, let's have a go at this one together then. So this is example 2. So let's write down what my sequence is first. My sequence is 7, 11, 15, 19, and 23. So remember, we're using Dino, which stands for the difference, n, and then my 0th term. So the difference in this one, well, how do I get from 7 to 11, 11 to 15, 15 to 19? Well, it's going to be plus 4. Yeah, plus 4, plus 4, plus 4, so that means it's going to be 4n, like so. And then I find my 0th term. So we know that this is our first term, second term, third term, but we're going to work backwards to find our 0th term. We do that by doing the opposite of this, which is minus 4. So 7 minus 4 is 3. It's positive 3, so it's going to be 4n plus 3. Super. Brilliant. Now, this is one of those things that always seems so easy when you're first taught it, but it's all about remembering it, and it's all about remembering how to do it, which is why practicing is so important with these. So let's just check those answers. 2n minus 1 and 4n plus 3. Super. So let's have a go at another 2. So the nth term of sequence goes 2, 6, 10, 14. find, it says u of n here. Now u of n is just another way of saying the nth term, and it even says it at the top, find the nth term, but I'll put this one in there because I didn't want you to get worried by different things that come up. So this one here is example 3. You might want to pause now and have a go at these two if you really want. I'm going to go through both of these now then. So the first one is 2, 6, 10, 14. So what am I going up by? Well, I'm going up here by 4, aren't I? Plus 4, plus 4, plus 4. So it's going to be 4n. And then I find my 0th term by going to the, so this is my first term, I find my 0th term here by minusing 4, so going the other way. So 2 minus 4 is minus 2. So it's 4m minus 2. And you can sub anything into that and it will give you one of the term values in this. So if I wanted my 1, 2, 3, 4, 5th term, I'd sub in 5. If I wanted my 4th term, I'd sub in 4. Let's just check that. 4 times 4 is 16. Take away 2 is 14. So brilliant. So let's have a look at this next one, example 3. I'm going to suggest that you pause again and have a go at it yourself. Remember, it's all about practice with this one. So hopefully you've paused and had a little go at it. So it's 4, 9, 14, 19, and 24. So what am I going up by each time? Let's have a little look. Well, that one's going up by plus 5, plus 5, plus 5, like so. So that means it's going to be 5n. Remember, the d, this is the difference. D, no. So the di stands for difference. N stands for the n, which comes after that. And then the 0 stands, sorry, the d, no. The o stands for 0, which is our 0th term. So I'm going to go back one here. So minus 5, which is equal to 4 minus 5 is minus 1. So this is 5n minus 1. Brilliant. So we've had a go at those two. Let's just check those answers. Brilliant. U of n is 4n plus 2. Okay. So we've got a couple more here. So let's have a look at these ones then. Now, I'll make these big for you. What's the first thing that you notice with these ones here? See if you can spot it. What's different about these ones? What's making this one harder than the others I've just had? So hopefully you could spot that. Well, with this one, they're not increasing, they're decreasing each time. So here, this is example 5. So example 5, so we've got 7, 5, 3, and 1. So what's happening here? Well, actually, when I'm going here, I'm doing minus 2, and minus 2, which means it's going to be minus 2n, like so. And then my 0th term, well, here, this is my first term, second term, third term, 4th term. So to go for my 0th term, I go the opposite way. So instead of minusing 2, I'm going to add 2, which means that it's going to be 7 plus 2, which is 9. Brilliant. So it's going to be minus 2n plus 9. You do need the plus in between there, okay? I know I've got 9 there, but you need to make sure you've got it as an expression. You can't just add 2n 9, okay? So I'm going to suggest that you pause now and have a little go at that one on the right. I think we should be flying through these at the moment. So pause now and have a little go at that one on the right. Okay, I'm going to go through it. So here we've got example 6. So it's 21, 19, 17, and 15. So let's see. What's my common difference? What am I happening here? Well, notice it's going down again. And what's it going down by? Well, 21 to 19, it's going down by 2, minus 2. So it's going to be minus 2n there, like so. And then what's my 0th term? Well, I do my 0th term, I go in the other way here, which is plus 2. So that's going to be equal to 23. So minus 2n plus 23. Super. Brilliant. So that's those two questions done. I feel as if we are flying through these today. Just check those. Brilliant. They were both U of N questions. Alright. So there's only one thing that makes this a little bit trickier, really. As soon as you've got this technique and you understand it, you should be flying through it. But there's one little part here which makes this a little bit trickier, and it's this one. So let's make it big so you can see it. So here is a sequence of patterns made with counters. Find an expression in terms of n for the number of counters in pattern n. Now notice it doesn't tell you here any numbers. It's just about the pattern numbers. Okay, so the only thing that makes this different is you've got to work out what the pattern is first. Now we do that if it's just the number of counters. Well, I'll draw this one here. What example was this? Example 7, is it? So we've got 1, 2, 3, 4. So my first term is 4. Nice and easy. Then it's 1, 2, 3, 4, 5, and then 1 there, and then 1 there. So it's 1, 2, 3, 4, 5, 6, 7. So that's 7. And then the next one is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and 1 there, 1 there, and 1 there. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 there. So what is making this different? Well, they don't tell us what the pattern numbers are, do they? So what we've got to do is we've got to figure out what those pattern numbers are. So with this one, it was 4, 7, and 10. So to find out the nth term of this, it's just exactly the same process, and I think you're probably completely fine with this now. So this here, what's happening? Well, it's increasing by 3, so plus 3, which means it's going to be 3n. Super. And then, so 3n, I find my 0th term, which is going to be minus 3, so 4 minus 3, which is 1. So 3n plus 1, brilliant. So the only difference here is that I worked out what that pattern was there. So have a go at that one on the right. It is a little bit trickier here because it says find an expression for the perimeter of the nth term. So you've got to know what that perimeter means. Okay, so let's have a little look at example 8. So there's a few things going on with example 8. We've just got to be a little bit careful with this one. So it says find the expression for the perimeter of the nth term. Okay, but it also says that the sequence is drawn below is made of equilateral triangles of side 3. So let's draw out my shapes. So here's my first one. Here's my second one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And then the last one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Brilliant. Now the thing is here, it's asking for the perimeter, which is the outside of the shape. And it's also saying that each side length is 3. So the perimeter of this first one is going to be 3, 3, and 3. Okay. So just check this. Below is equilateral triangle sides of 3 centimeters. So 3, 3, 3. So this here is 9. So the this one here is going to be 3, 3, 3, and 3. Not including that one because it's not part of the perimeter. So 3, 6, 9, 12. So this one here is 12. Then it's 3, 3, 3, 3, 3, 3, 6, 9, 12. 3, 6, 9, 12, 15. I think we start to see what the pattern is now. 3, 15, 18 on that one. Brilliant. So just a couple of extra little parts there. We've got the perimeter being 3 centimeters. It says the perimeter and not the length. So some people might find the sequences of the lines. So here, what am I going up by each time? Well, I'm going up by 3 each time, aren't I? Plus 3, which means that it's going to be 3n. And then I need to find my 0th term, and I do that by minusing 3, which in this case is going to be 6. So 3n plus 6 for that one there. Just a few little extra bits there, nothing to be too worried about. Let's check both of those answers. So 3n plus 1, super, and 3n plus 6, absolutely perfect. So, got some questions here now. I'll make this big for you so you can have a little go at it. So pause now and have a little go at those. So pause now. Okay, well done for completing those if you have. So I'll put the answers on, so mark these in green for me. Mark those in green. Super, so thank you for watching this video on finding the F term. Do make sure you're having a go at these, because remember, the only way to learn maths is to do it, and have a lovely day.